Okay, so for our special angle triangles, we're not going to spend a lot of time on this because, to be honest, we're going to use our calculators mostly, and we've always got them. If a question says don't use your calculator, we're going to use our calculator to cheat a little bit. But here are the special angle triangles, and I'll show you maybe how to use your calculator to try and cheat a little bit. Okay, so if we wanted to know these special trig ratios for the angles 45, so we'd have a triangle that has 45, 45. There's our right angle triangle, must be, and our isosceles triangle. If we let the small side equal 1, which is always going to be our trick with our special angles, what would the length of our hypotenuse be? Well, we just use Pythagoras to help us. 1 squared plus 1 squared is 2 at least, and therefore this length must be the square root of 2. And then we can just use our SOHCAHTOA to figure out what these are. Sine is opposite over hypotenuse, so it doesn't matter which 45 you choose, it's going to be 1 over root 2. If you chose this 45, it would be 1 over root 2. So 1 over square root 2. Now, you put this in your calculator and you say, well, my calculator, I can just write in sine 45. Yet it tells me square root 2 over 2. Now, they're the same number. They're just different ways of writing it. The calculator always does what we call rationalizing the denominator. It makes the bottom number a rational number. So not this third number. What it's done is it's multiplied this by square root 2 over square root 2. That means that square root 2 times square root 2 gives you 2, and 1 times square root 2 gives you 2. So that's what it's doing. But 1 over square root 2 is what we get from our diagram. Similarly, cos 45, cos is adjacent over hypotenuse, so it's also 1 over square root 2, and again the calculator is going to tell you this form. And tan of 45, this is a useful one to remember. Tan is opposite over adjacent, or opposite over adjacent. That's just 1, and the calculator is just going to tell us that tan of 45 gives us 1. So that's how we remember those, and what's happening with our calculator, why it's giving us different values, or so it seems. Okay, so for our other one, what about if we've got 30 degrees and 60 degrees? Well, let's make the shorter length 1 and make a bigger triangle. And if that's 1, and we basically just make the same thing but reflected, this would be 1, and we're making this angle at the bottom 60 degrees. We're going to make an equilateral triangle. Now, equilateral triangle has 60 degrees, 60 degrees. If this whole thing is 60 degrees, then this side must be 30 degrees. It's half. Also in this triangle, 60, 90. Other one must be 30. This side length here, it's an equilateral triangle, so this whole side length is 2. This must be 2. Pythagoras to the rescue to figure out that that's square root 3. And we can say sine 30, so sine is opposite of our hypotenuse, is a half. As you can imagine, the calculator is just going to give us that one straight up. Sine 30 gives us a half. No, it does a half out, yes. And cos 30, well, cos of 30 is adjacent over hypotenuse, which is square root 3 over 2. Cool, that one, cos of 30 degrees is square root 3 over 2. And tan of 30 degrees, well, this one here, tan of 30 is opposite over adjacent, so it's 1 over square root 3. What do you think the calculator is going to give you if it's doing this rationalizing thing? Let's do it. Tan of 30 degrees gives us square root 3 over 3. Again, it's done this thing here, this rationalizing of the denominator. Okay, and sine 60 and etc. we could get these from our diagram and fill them in if we wanted. Root 3 over 1. Root 3 over 1 is just root 3. So without the use of a calculator, as I said, we're not actually going to do too many of these. When you do them later this year and into next year, you really end up just substituting, put these into your calculator and run through them. So here we will go 4 times sine of 30, you know from your diagram, is a half, or you plugged into your calculator. Cos of 45 we know is 1 over square root 2 multiplied across 4 and the 2 cancel with 2 left on the top, so we're 2 over square root 2, and our calculator will tell us that that's just the same as square root 2. Let's check it. 2 divided by square root 2 equals square root 2. Okay, without a calculator, sine squared 60, just remember that's squared over cos 60. Determine what the left-hand side is. This is the left-hand side. Then determine what the right-hand side is, and you'll see that they equal to each other. As I said, really not going to spend too much time on that and focus on our other bits of trig.